we're going to go over Chapter 1, Introduction to Statistics.
We are looking at Module 1 of Elementary Statistics. This practice test for Module 1 covers Chapters 1, 2, 3, and here's Chapter 1, Introduction to Statistics. Chapter 2, Exploring Data with Tables and Graphs. Chapter 3, Describing, Exploring, and Comparing Data. We are going to look at Chapter 1, Introduction to Statistics, starting with a true-false question. The value of variance and standard deviation is never negative. This is a true statement because we are looking at absolute quantities, that refers to variations, and we are dividing by a positive value. What do we mean by that? Let's look at all formulas. Here's the formulas for the populations. Sigma, we use Greek letters for population and Latin for sample. In this case, sigma squared is summation of x minus mu quantity squared over n. So no matter what this is, when you square it becomes positive, and it's the summation of those, and so is n, the population size. The standard deviation is the same thing. You take a root. For a variance, you divide by n minus 1. So this is a true statement because these are all absolute quantities. That is a measure of variation of all values from the mean. It can be 0, by the way, which is ideal in some instances. What kind of variable weights of bear is? Quantitative or qualitative? It's a quantitative variable. Basically, it gives numbers that represents count or measurement. What about gender? That's qualitative. It's distinguished by non-numeric characteristics. So weights versus gender. We want to define population and sample. Population is the complete collection of all elements, scores, people, measurements, etc., to be studied. Sample, a sub-collection, portion or fraction of elements drawn from a population. In short, population refers to the whole, and sample refers to a portion of that. The value of the middle term in a ranked data is called the median. What about mode? We want to look at the definition of a mode. Mode is the value that appears with the greatest frequency among the data. A data set can have one, more than one, or no mode. When all numbers appear with equal frequency, we don't have any modes. True or false? The number of chairs is a continuous variable. This is a false statement. The number of chairs is not continuous. We cannot have 1/4 of a chair. It is a discrete value. Discrete. Data results when the number of possible values is either a finite number or a countable number of possible values, such as 0, 1, 2, 3. By the way, those are considered whole numbers. Number of students in a class, number of cars in a parking lot, and things of that nature. A continuous data that can take any value in an interval. Data results from infinitely many possible values that corresponds to some continuous scale that covers a range of values without gaps, interruptions, or jumps. Examples would be the weight or height of a person. What about the Pareto chart? What does each axis represent? A Pareto chart is a bar graph for categorical or qualitative data, similar to histogram for quantitative data. The vertical scale represents frequencies or relative frequencies, and horizontal scale represents different categories. Bars are arranged in descending order to emphasize the order of impact. Define a parameter and a statistics.
A parameter is a numerical measurement describing some characteristic of a population, while a statistic is a numerical measurement describing some characteristic of a sample.
Define random sample and simple random samples.
Random sample members of the population are selected in such a way that each individual member has an equal chance of being selected. Simple random sample subjects selected in such a way that every possible sample of the same size n has the same chance of being chosen.
So in short, what's happening here? Parameter refers to some sort of a numerical measurement describing population. Statistics goes for a sample. Random sample, every member has an equal chance of being picked. Simple random sample, known as SRS, every sample of the same size will have an equal chance of getting picked. It's important to understand the concept here in the following manner, that if we have 30 students in a class, then if we want everybody to have an equal chance of getting picked, if we are picking one student, then random sampling takes place and every student has 1 out of 30 to be picked. However, if you are interested in a sample size of, let's say, 5 in a class of 30, first we have to figure out how many of those there are, which uses a combination 30 choose 5, and then each one has an equal chance. Bear in mind that even if we change one subject, it's a new sample. We want to define the following types of sample: systematic, convenience, stratified, and cluster.
Systematic sampling, select some starting point and then select every kth element in population. Example, in a population of 50,000 people, a statistician selects every 100th person for sampling.
Convenience sampling, basically, we use results that are easy to get. Here's an example: standing at a mall or a grocery store and asking people to answer questions would be an example of a convenience sample. Or if I'm interested in knowing what people think about a specific topic, such as climate change, I can simply ask my students. That would be a convenient sample. Sometimes we may not have a choice. Stratified sampling.
Divide the population into homogeneous. The subjects within the same subgroup must be similar and share the same characteristics. Subgroups called strata, and then obtaining a simple random sample from each subgroup stratum.
Cluster sampling.
Divide the population into sections or clusters, non-homogeneous subgroups, then randomly select some of those clusters and choose all the members from the selected clusters.
Just to have an idea how that works with the stratified sampling, they are the same. The groups that you're looking at, they are the same. You pick a few from each. But with the cluster, you pick it such that every group contains a random sample that is the representative, and you can pick one of those clusters or more than one and keep each and every one of the subjects. What are different levels of measurement of data? Give examples. Nominal.
Nominal level of measurement is described by data that consists of names, labels, or categories only, and the data cannot be arranged in some order, such as low to high. Example, survey responses of yes, no, and undecided, eye colors, blue, brown, black, other, political party, Democrat, Republican, Independent, and other.
Ordinal.
Ordinal level of measurement involves data that can be arranged in some order, but difference obtained by subtraction between data values either cannot be determined or are meaningless. Examples: ranks of colleges. Ranks can be first, second, third, and so on, which determines an ordering. Assigning grades of A, B, C, D, or F. These grades can be arranged in order, but we can't determine difference between the grades.
Interval level of measurement.
Interval level of measurements involves data that can be arranged in order, and the differences between data values can be found and are meaningful. However, there is no natural zero starting point at which none of the quantity is present. A value of 0 does not mean the absence of the quantity. Arithmetic operations such as addition and subtraction can be performed on values of the variable. Examples: body temperatures of 98.2 degree Fahrenheit and 98.6 degree Fahrenheit.
And the last one, ratio level.
Ratio level of measurement data can be arranged in order differences can be found and are meaningful, and there is a natural zero starting point where zero indicates that none of the quantity is present. Differences and ratios are both meaningful. Arithmetic operations such as multiplication and division can be performed on the values of the variable. Examples: distances traveled 0 kilometers represents no distance traveled, and 400 twice far as 200 kilometers. Prices of books: $0 does represent no cost, and $100 but does cost twice as much as $50 books.
As far as the level of measurement is concerned, in short, things involving numbers are considered numerical and they become either interval or ratio. If not, they are ultimately qualitative. Normally, they become nominal. But there are numbers that are considered qualitative, such as zip code or your student ID. Those are, although numbers, they are still considered qualitative. And so we want to distinguish between them, quantitative data. As far as the interval level of measurement, again, nominal, basically qualitative. Ordinal, there is some sort of an order, small, medium, large. Interval, you have numbers, and the zero doesn't have much of a meaning, and arithmetic operation can be done. Ratio, everything goes, including zero, does have a meaning. Zero means non-existence in essence. What's the difference between an observational study and an experiment?
Observational study, observing and measuring specific characteristics without attempting to modify, influence the individuals being studied. In an observational study, the researcher merely observes and tries to draw conclusions based on the observations. Example, a study took a random sample of adults, asking them about their bedtime habits. The data showed that people who drank a glass of warm milk before bedtime were more likely to go to sleep earlier than those who didn't.
Let's look at an experiment.
Apply some treatment and then observe its effects on the individuals. The individuals in experiments are called experimental units, and they are often called subjects when they are people. In other words, an experiment is a controlled study that aims to determine the effect of one or more independent explanatory variables or factors on a dependent outcome response variable. Any combination of the values of the factors is called a treatment. The researcher manipulates the independent explanatory variable and tries to determine how the manipulation influences the dependent outcome response variable in an experimental study. Example, another study took a group of adults and randomly divided them into two groups. One group was told to drink warm milk every night for a week, while the other group was told not to drink warm milk that week. Researchers then compared when each group fell asleep.
In short, in the case of an observational study, we simply observe and we make sure nothing is changed and influenced by the one who's studying it. Whereas in the case of an experiment, you actually apply a treatment to see what happens as a result. Describe cross-sectional, retrospective, and prospective studies. Give examples.
Cross-sectional study, data are observed and observational study measured and collected at one point in time. A cross-sectional study is like a snapshot of a particular group of people at a given point in time. It is used to describe what is happening at the time. Example, a medical study examining the frequency of cancer among a population of different geographical locations. By doing this, any differences among them can most likely be attributed to geographical locations differences rather than something that happened over time.
Retrospective or case control study. Data are collected from the past by going back in time, data that already exist. Example, researchers ask participants about their smoking habits over the past 20 years. Then they can analyze any possible correlations between their smoking habits and diseases such as lung cancer.
Prospective.
Perspective or longitudinal or cohort study. Data are collected in the future from groups called cohorts, sharing common factors. Longitudinal studies look at a group of people over an extended period. Example, a medical study follows a cohort of middle-aged people who vary in terms of smoking habits to test the hypothesis that the 20-year study of lung cancer will be higher among heavy smokers.
So, in short, we have the present, cross-sectional, past, retrospective, and future prospective study. What is a sampling error, non-sampling error, and non-random sampling error?
Sampling error is the difference between a sample result and the true population result that is consequence of chance sample variations.
Non-sampling error?
Non-sampling error. The non-sampling error occurs due to data that are incorrectly collected, recorded, or analyzed. It may happen by selecting a biased sample, using a defective instrument, or copying the data incorrectly.
Non-random sampling error?
Non-random sampling error is the result of using a sampling method that is not random, such as using a convenience sample or a voluntary response sample.
Finally, voluntary response.
One in which the respondents themselves decide whether to be included. In this case, valid conclusions can be made only about the specific group of people who agree to participate.
So various errors can happen. The sampling error is important. It could happen by chance because there's a difference in size. And that's why the random sampling is important and the size are also important. Non-random, non-sampling error, normally when there is some sort of a mistake involved. What are some characteristics of an experiment? Confounding occurs in an experiment when the experiment is not able to distinguish between the effect of different factors. Blinding subjects. Subject doesn't know he or she is receiving a treatment or placebo. Groups of subjects with similar characteristics are called blocks. Completely randomized experimental design. Subjects are put into blocks through a process of random selection. Replication of an experiment when there are enough subjects to recognize the difference in different treatments. Sample size, it must be large enough to display the true nature of the population data and should be obtained using an appropriate random method. We want to explain some misuses of statistics.
Bad samples, small samples, misleading graphs, distorted percentages, loaded questions, order of questions, refusals, correlation and casualty, self-interest study, precise numbers, partial pictures.
The idea is that, remember, statistics is a fantastic tool, but it can be misused. And when you read the research, you should pay attention to that. Pictograph.
Pictograph. Double the length, width, and height of a cube, and the volume increases by a factor of 8. To correctly interpret a graph, we should analyze the numerical information given in the graph instead of being misled by its general shape.
So when you double it, 2 cubed, that becomes 8 times. Deliberate distortions.
Loaded question. 95% yes, should the governor have the line item veto to eliminate waste? 53% yes, should the governor have the line item veto or not?
Clearly, we can see the difference between the two questions. So if sample data are not collected in an appropriate way, the data may be completely useless. That no amount of statistical training can salvage them. Randomness typically plays a critical role in determining which data to collect.
Research Center questioned 2,000 adults in the US to estimate the proportion of the population favoring death penalty for murderers. It was found that 70% are in favor of death penalty for murderers. State the individual, variable, population, sample, parameter, and statistic.
So for a question like this, what is the population, all adults in the US? What would be the sample, those 2,000 that we asked, we surveyed? Individual, one adult in the US. Variable, you are favoring it or you're against it. So favoring the death penalty for murderers, that would be the variable. Statistics, this is the number, pertains to those 2,000, 70% in favor. The parameter is not given. I want you to know that. This question may not be asked. So parameter is not given. However, if the question is asking you for that, then you use the statistics for that because you are assuming this will pertain. But please understand, this is not given. Here's the last question. Decide if each of the following describe an observational study or an experiment. The height of shoppers at the mall was recorded. That is clearly just observing. So we are looking at observational study. A drug is given to a group of people and their reaction observed. So we are experimenting. A group of students are told to listen to music while taking a test, and the results are compared to a group not listening to music. We are experimenting. The temperature on randomly selected days throughout the year were measured. We are simply observing. It's observational study. The gender of children born in January were tallied. The same thing. We are observing. Observational study. The growth rate of bacteria is compared before and after adding alcohol. Clearly, we are experimenting.